All right, this is a video that's going to introduce our next topic, which is experimental design. And before we get into actually designing and explaining and doing questions about experimental design, we have to know a little bit of vocabulary that we're going to refer to. So this is all the vocabulary we need to know. So this is called homework 4-6, but we're going to actually put this in our notebook, and it's going to be linked to your class notes, okay? So the first thing we need to talk about is the difference between an observational study and an experiment. So this question says, is taking a vitamin D supplement good for you? Hundreds of observational studies have looked at the relationship between vitamin D concentration and person's blood and various health outcomes. So notice here the key word that it says is observational study. An observational study is exactly what you think it is, which is they're just merely observing and recording results. Merely observing what happens and recording results based on some pre-existing conditions that are occurring. So basically people may be reporting that they take vitamin D, and then they may be reporting that they had better health and better blood results. So in this situation, there is no manipulation of the person who's taking the vitamin D. It's basically like the people who we're going to talk about are called subjects are reporting that they take vitamin D, and then they're also reporting about their blood and their health, but we're actually not manipulating them in any way. They're just telling us about it. So this is an observational study because we're merely observing it, but we are not imposing that vitamin D on the participants. So as a result, we can't necessarily conclude causation about vitamin D and if it's good for you or not. The only thing we can do is conclude correlation. So we can say maybe there's an observed relationship or some kind of correlation, which we talked about last unit, but we may not be able to conclude causation. And the reason why is because we're not the ones who are imposing the vitamin D on these people. And so there may be other variables that may cause these people to be healthy. Maybe they're people who exercise. Maybe they're people who go to the gym. Maybe they're people who eat very well. Maybe they eat a well-rounded diet. Maybe they only eat organic fruit. That maybe they take supplements besides vitamin D. So there's all these other variables that could be the reason of the explanation of why they have good health. And since we're not manipulating them, we don't know. Okay, so now there's going to be two types of variables here that we're talking about. There's an explanatory variable and a response. We talked about in the last unit that the explanatory variable was the variable that went on the x-axis, and the response variable went on the y. So similarly here, the explanatory variable is the one that's explaining what's happening, and the response variable is what is responding as a result. So in the case above, the explanatory variable would be taking vitamin D or not as a supplement, and then the response variable would be what I'm measuring. So it looks like I'm measuring the blood and health outcomes. Okay, so the response variable is what we are measuring at the end of the study. What we're recording, what we're measuring, basically what we're trying to draw conclusions about. And then the explanatory variable is basically what's being imposed on the subjects that's supposed to serve as an explanation of the response. I'll say what is being investigated. That's not good because that sounds like what we're measuring. Is causing. Let me put a question mark because we can't really establish causation. What is being investigated is causing the result. Okay. So, I mean, the explanatory variable is basically the one that we think is explaining the other one. I'm going to put a question mark for causing because we don't know if it's causation or correlation. It's what is being investigated is explaining the result. Let's use the word explaining the result of the response variable. Okay. All right, so now the problem is, like I said above, there could be a third variable existing here, and that third variable or fourth variable or many variable is basically another variable out there that could also be explaining the response. So above we were measuring how vitamin D could help with blood and other good health, but there could be the other reasons that I said out there that are lurking that could cause that response. So examples include their diet, their exercise habits, other supplements that they take, etc. Maybe they meditate, okay? So that extra variable we refer to with the letter Z usually, and that is another variable. It could be a third variable or more than one other variable that can be explaining or causing the response. And basically, because it could also play a role, we're kind of confused by it. So you see the word confounding kind of looks like confused. We're kind of confused about, is this variable causing the result or the other one? So we could say it gets in the way of concluding causation that the X variable is causing the response. All right, so I know that was a lot, and I'm just going to reread it. It's this other variable that exists out there that could also be explaining the response, and basically it gets in our way so we can't conclude that indeed the X variable is causing the response. So we can conclude indeed that vitamin D is causing the response. Okay, so if you look down below here now, you see three circles. The first circle is the X, the second one is the Y, and the third one's going to be the lurking variable or confounding variable Z. Sometimes we call it a lurking variable because it's like lurking in the shadows and we don't realize it, but that's what's causing the result. So in this first example is the X variable of vitamin D, taking vitamin D, causing the response variable of better health, better or less, depending on if you take it or not. If it is, if there's this solid arrow means causation. Okay, so is X indeed causing Y? We're not sure because this is an observational study. Or is there just a correlation? And this dotted line means correlation. So is there some kind of association or observed relationship between taking vitamin D and your health improving? Maybe, right? Maybe X does cause Y, right? But maybe there's this third variable out there that's causing me to have better health as well. Maybe I exercise a lot, which I should, right? Maybe my diet, my what I eat in my diet, I eat a lot of vegetables, could cause me to have better health. Maybe I meditate. Maybe I get a lot of sleep. My sleep habits are good. This is not true for me, by the way. Maybe I take other supplements. Maybe I juice all my vegetables, whatever. So any of these things could cause us to be confused. So I'm going to put a question mark here showing we're not sure if X is causing Y or Z is causing Y. And we're confused. We say that X is confounded with Z, meaning the vitamin D and taking vitamin D is being confused or confounded with maybe your exercise habits. And we don't know how to conclude the response. We don't know if indeed the health is improved because of X or because of Z. Okay? So that's that. And that's going to come up a lot with observational studies because we don't really know. So keeping this in mind, we see that they define here the variable, the X variable vitamin D. Then they define that they have a different strategy here. they have group 1 and group 2, people who take high vitamin D versus low, but then they also talk about they have all these other things, better diet, worse diet, exercise. So basically we don't know which variable is causing the result. Is the vitamin D taking causing them to have diabetes or not? That's the response variable. Or is it their exercise habits? We're confused. We're so confused with all these different variables. So if you look down below, it says to determine if vitamin D actually causes the reduction in diabetes. Now we're going to do what's called an experiment. An experiment's going to be different because the treatments, which are going to be the use of vitamin D or not, are actually imposed deliberately on the subjects, which are the people who are participating in the experiment or the experimental units, if they are like animals or plants or whatever. And they are imposed on the subjects by a researcher. So we're telling them, okay, you guys go take vitamin D, you take a placebo, but we're not going to tell them it's a placebo, which we'll get into in a second. So researchers randomly assigned, so notice we have random assignment here, that's very important for the treatments, 500 people to either take the high dose of vitamin D or to take a placebo, which is the pill that looked exactly like vitamin D, but it actually contained no active ingredient. So that's what the placebo is. We call it a dummy treatment, which doesn't really mean that you're a dummy, but it actually just means it contains no active ingredient. And that's going to be used for the control group, which is who we're comparing to. Okay. So then once we have our two groups, we have one with vitamin D, one without, then we're going to, after 5 years, we're going to measure the amount of people who are diagnosed with diabetes. And that is going to be my response. Okay. So my explanatory variable is use of vitamin D or not. My response variable is do you have diabetes or not after 5 years. My groups are my treatment group, which is vitamin D, and they're the people who are really taking the real vitamin D, and then the placebo group, which is no active ingredient, okay? So the treatment in this case is vitamin D or placebo, and it's basically what is being imposed on the subjects or the units. What condition is being imposed on the experimental units, okay, or subjects. And now if the person is a person, we call them a subject. And if the person is like I'm sorry, if it's not a person, if it's an animal or a plant, we just call it a unit. So it's who or what is being experimented on. And if they are humans, then they are called subjects. If they are plants or animals or whatever, then they're called units. Plants, objects, fields, grass, dirt, animals, then they're called unit. Okay? So this is a lot of vocabulary. No, it's a lot of vocabulary, but we're going to refer to all of it soon. So here's an example. Malaria causes hundreds of thousands of deaths each year, with many of the victims being children. Will regularly screening children for malaria parasite and treating them who test positive reduce the proportion of children who develop malaria? Researchers work with children in 101 schools in Kenya, randomly assigning half of the schools to receive regular screenings and follow-up treatments and the remaining schools to receive no screenings. Children at the 101 schools were tested for malaria at the end. So it says identify the treatments and the units, okay? So let's first start with the units. Who is being experimented on? And you may think that it's the children, but actually it sounds like it's the schools that are being treated. So it's going to be 101 schools, and they're called units because they're schools. And obviously the schools contain children, and the children are going to be getting the result of the treatment. And then what are the treatments? Well, there are two treatments. Okay, the one is the experimental group, is going to get the receive regular screenings and follow-up treatments for malaria. And then the other group is going to be called the control group, and they're going to get nothing, no regular screenings. So we want to compare the treatment group, the ones who are actually getting the screenings and the treatment, to the other group in order for us to conclude the results, okay? Now also keep in mind, if we had to explain the explanatory variable and the response, the explanatory variable, or the X, would be kind of similar to what the treatments are, which is the screenings for malaria. And then the response variable, or the Y, would be what they're measuring, which is going to be, in this case, it says tested for malaria. So number of or percent of children with malaria at the end. So response is like what we're measuring, and usually it's quantitative, numeric, okay? All right, so the last little piece, I actually just use these vocabulary words up above, are control group. So the control group is the group used as a method of comparison in order to evaluate if the treatment is indeed successful or causing the result. You need a method of comparison. Otherwise, if you don't have a control group, you're basically just looking at one group, and maybe they all go up or down for something, but we don't know why. They may be another lurking variable. So we need that control group or comparison group in order to evaluate if indeed the treatment is causing the result or if something else is causing the result. So that's really important. You can't just have one group, because then you have nothing to conclude about. So that control group could receive a placebo. They could receive nothing at all, no treatment at all, or maybe they could receive something like a standard formula, like if you're talking about shampoo, new shampoo, old shampoo. I don't really say old shampoo, but like old formula shampoo. So very important that we use random assignment in order to assign the treatment. So we're going to use the same kind of randomization that we use in the SRS to create the treatments, to decide which groups are getting the treatments, to create the treatment groups. So we have to make sure we use some kind of randomization, and the randomization could be a random number generator, table random digits, a coin flip, to assign the treatments. And that's going to make things a lot more equal, because we're not going to deliberately or subjectively give one group the treatments and not the other. It's going to kind of just use chance to do it. So to create roughly equivalent groups at the beginning of the experiment, we use our random assignment. Okay? So that's it for now. I know that that was a lot of me talking. I appreciate you listening, but it's a lot of foundational vocabulary that we're going to use now when we go implement it in the form of our experimental design AP free response questions.